Welcome to lesson 6, the nervous system. My name is Christian, I'm the author of this lesson. This is going to be a follow-up to the level 2 lesson on the nervous system, where we covered the basic functions and locations of the various parts of neurology. Going into this section, we're going to expand on that, give it a little bit more context, and go into a lot more detail on some of the key functions around the nervous system and how important it is for the other systems in the body to do their job. So the learning objectives for this lesson are as follows. By the end of the lesson, you'll be able to have a deeper understanding of the nervous system's role in health and exercise, to understand the difference or differences in different branches of the nervous system, know how to develop a thought process behind how the nervous system underpins the other bodily systems, to be able to understand the difference between afferent and efferent nerves, understand the importance of our language and our environment's role in homeostasis, and to understand the basics behind pain and our boundaries as fitness professionals. So some of the fundamentals that we'll recap from level 2 will be here. If this is new to you, not to worry, this is a good starting point to understand the rest of the lesson within context. So there are around 7 trillion nerves and around 100 billion nerve cells or neurons in the human body. The nervous system underpins the other systems in the body and is referred to as the master system. So that basically means that it oversees and dictates and influences what all the other systems do around the body. Without a nervous system, we wouldn't be able to perform tasks such as simple tasks such as picking something up, or complex tasks such as running and jumping. It also is needed to be able to perform functions that we need to survive, such as heartbeat, circulation and breathing. The science of the nervous system is what we call neurology, with the doctors of neurology being neurologists. The nervous system is made up of 2 main branches, which are the central nervous system, CNS, and the peripheral nervous system, which we'll refer to as PNS. Okay, so here we have a bit of a flow diagram of the nervous system. As you can see, it's split into CNS and PNS. The PNS is also split into 2 further subdivisions of somatic and autonomic, and the autonomic is split into another further 2 subdivisions of sympathetic and parasympathetic. So it's worth taking the time to see this visually and try and memorize this flow, because it's going to be really important for helping you to understand the rest of this lesson. So the central nervous system is made up of the brain and the spinal cord, as we already know. It's responsible for most body and mind functions, including thought and movement, and acts as a conduit or a conduction for signals between the brain and the body. What's important to know and remember is there's 31 pairs of nerves that attach to the spine, that come in the form of 8 cervical, 12 thoracic, 5 lumbar, 5 sacral, 1 coccygeal, each connecting the spinal cord with a different area of the body. It's important to differentiate these numbers from the ones of the segments of the spinal column, which was 7 cervical, 12 thoracic, 5 lumbar, 5 sacral and 4 coccygeal, so that we don't get the 2 mixed up. Then we have the peripheral nervous system, so the PNS, which is all of the nerves that lie outside of the CNS, and its primary function is to connect the CNS to the organs, limbs and skin. Secondary function is to allow the brain to send information to other areas of the body, allowing us to react or respond to the stimuli in our environment. As we said earlier, the PNS has its own subdivisions that divide into the somatic and autonomic nervous system branches. Moving into the somatic nervous system, the word somatic derives from Greek. Like a lot of words in this course will derive from Greek and Latin. It's responsible for carrying sensory and motor information to and from the central nervous system. And you can think of it as conscious. So movements that are consciously controlled, such as writing with a pen, catching a ball, picking something off the floor, all are driven through the somatic nervous system. The somatic branch contains two major types of neurons within itself, which are sensory neurons and motor neurons. Now, the autonomic nervous system, in contrast to that, is responsible for regulating involuntary body functions. We already mentioned blood flow, breathing, heartbeat, but also things like digestion and blinking to an extent as well. You can think of this as automatic, so automatic for autonomic, and it's responsible also for fight, flight, or freeze response, which I'm sure the majority of you will have come across before. The autonomic nervous system is broken down into further subdivisions of sympathetic and parasympathetic branches. Here we have the sympathetic system, which is known as an accelerator, or something that turns everything on, all of the body processes being turned on. An example with this would be in the fight, flight, or freeze, as I just mentioned, in the response to threat or danger, where your heartbeat would become accelerated. You put more blood around the body to the extremities and the working muscles. Adrenaline would be released in order to help you to survive. So what this does is allow you to make better decisions. So it comes to fight or flight. Unfortunately for some people it also means freeze, but this is a survival mechanism that is very, very important for all animals and living things, with the exception of plants. So we know sympathetic is acceleration, so in contrast, parasympathetic is deceleration, or turning everything off. Now in that fight, flight, or freeze situation, once there's no danger, there's no reason for the body to remain in a heightened state of stress. So it does its best to return to homeostasis, or that steady state of equilibrium that you will already know. Now an example of a danger situation might be being chased by someone with a knife, or somebody about to mug you in the street. But it can also just be anything where you feel threatened from something external. The stress response itself, so the fight, flight, or freeze, is a modern day response that stays in people for longer than it needs to, and in higher levels than it needs to. And this is due to things like work, money, family, toxic exposure, poor emotional coping mechanisms, chemical exposure, and even man-made stresses like excessive TV and loud environments. What happens here is the body becomes sympathetically nervous dominant, or sympathetically dominant in the nervous system, and everything is in a turned on or accelerated state, unable to slow down. The consequence of this is that cortisol, a stress hormone, is secreted in higher amounts than needed, and the hormone adrenaline is also secreted in higher amounts, potentially leading to long-term chronic stress. There's a really good book on this that I highly recommend reading to really get an understanding of this, called Why Zebras Don't Get Ulcers, written by a guy called Robert Sapolsky. A story I took from this book, which I'll share with you now, is essentially that if you're a zebra, you will if you're getting chased by a lion, you're going to have two thought processes. It's either run away and survive, or you're going to stay and potentially fight and lose, or you're going to get eaten. So what you would do here, let's just go with the runaway situation. You will run away. Cortisol is pumped around your body, as is adrenaline. Your heart rate is elevated, and you are able to escape through your survival mechanism of stress response, which is a good thing in acute situations such as that. Where it becomes a problem is if you're a zebra and you've outran your lion, the lion is no longer a danger or a threat. So your sympathetic nervous system has no reason to stay accelerated. So to try and bring you back to homeostasis, your parasympathetic nervous system will bring you back down by decelerating all of those accelerated heightened responses back down to steady state of equilibrium. Now this is simple. For a zebra, it's black and white. Excuse the pun, I just had to get that in there. But with humans, it's a little bit more complicated because we are more complicated. With the situations like we said of money, family, stress, toxins, poor emotional coping mechanisms, we actually have smaller, more frequent bouts of stresses or stress in our lives as opposed to a big stressor like the zebra would have had in that situation. So what it means is for a lot of us, we actually never turn those systems off completely, and we're constantly being drip fed levels of stress that can eventually become harmful to the body. So this is why things like meditation, massage, flotation tanks have become more popular in recent years. But it's also just taking care of your body and having some time to yourself, away from all stimulus, and just being able to do nothing for a few minutes a day, which is harder than it seems for a lot of people. If we're able to do that, we're able to control our stress levels, because most illnesses, especially things like cancer, are traced back to heightened levels of stress for a prolonged period of time on some level. So it's very important we take control of our situation when it comes to our stress management, because it will have an impact on our health. It will have an impact on our results when it comes to the gym as well, because things like cortisol can lead to body fat storage in places you don't want, like around the stomach in particular. And high levels of adrenaline can lead to poor energy levels, because you're not able to sustain that steady state of equilibrium. Okay, so in this slide we're going to go into the components of a neuron. So familiarize yourself with this picture because it's going to be really helpful when it comes to your exams. These definitions are something that come up quite frequently. And here we've got the nucleus, which is this egg yolk shape structure over here. It can be thought of as the center of a cell body. You have the axon, which is this extension as one of the branches that connects between a cell body and the axon ending on the other side. The axon ending essentially connects to the end or the destination of a message that might be something like a muscle. The myelin sheath, this orange rectangular structure, is a protective layer of fatty tissue. And this protector of the cell actually allows us to transmit electrical impulses quickly and effectively along the nerve cells, protecting us for damage as we go. It's a really important function. We have the dendrites over here that kind of look like a tree root, and these are neuron segments that receive nerve stimulation to activate cells. This happens through the conduction of electrical messages to the cell body. Now, a good way to remember this is through an analogy that I use called the airport and the holiday analogy. So if you imagine above the dendrites in the top left, you have a brain, and let's call the brain your house. So you're in your house about to go on holiday. The axon endings on the other side that kind of look like a trident or a pitchfork, I've got a muscle on the other end of it. So the muscle is your final destination. So you're trying to create a desired movement. So from the brain, you're going to send a message to the cell body through the dendrites. So when you leave the house, you're going to go to the cell body, which we're going to call the airport. So you leave the house and go to the airport with your information, or in this case luggage, with the view of mind of going to your final destination, in this case a muscle. When you get to the airport, you check in, and what you're trying to do here is then distinguish which terminal you need to be going to get to the right destination. So you're going to have all of these different axons branching off in different directions to different destinations or different muscles in the body. So once you've checked in through the nucleus, your information or luggage is then put on with a fragile sign, which is this protective layer of myelin sheath, and is transported to the plane, which is eventually transported with you to your final destination. In this case, is the muscle that you want to contract. So what has happened is you've created, for example, a bicep curl. Now for every bicep curl, you're going to be sending feedback or a message back exactly the way you came. So you're going to go from your final destination to point B back to point A, which is your house, your brain and your nervous system. So you go back, get on the plane again, same process happens, you're checked in, and then what you end up doing is ending up back in the destination that you started because you've essentially returned from your holiday on a return flight. And I think this analogy is quite a good way to remember this, and it helps to really understand that there is a step-by-step process of going back to somewhere and then coming back from somewhere when it comes to sending messages, because messages are always two-way. There's the initial instruction and then there's a feedback that comes back with it. Within that, you have afferent nerves and efferent nerves. So if you think of the afferent nerves, are a type of sensory neuron that carry nerve impulses towards the central nervous system and brain. You can think of A as attract and A for afferent. Efferent nerves are motor neurons that carry neural impulses away from the central nervous system towards the muscles, causing movement. So think of that from the cell body to the end destination that we had on the previous slide. So you can think of efferent as E for exit. We also have something called neurogenesis. So neurogenesis translates as the creation of nerves. So genesis meaning creation and neuro meaning neurological or nervous system. It comes from Greek like a lot of the other words, as we've said, and it's the formation of nervous system cells. So when we're born, most of the nerves we have formed in the embryo are fixed. We cannot structurally change them for the most part, but there is some evidence that is coming through to say that neurogenesis occurs in human adults in the hippocampus region of the brain. Now, the hippocampus region of the brain is this red-shaped structure on this picture, and it is responsible for the creation and storage of new memories. And we'll cover this in the sleep cycle as well, because it's a very important thing to know. The sleep cycle is essentially there to filter out unnecessary memories and to store relevant memories in the short, mid and long term. Now, if we don't have enough sleep, we don't learn and we don't retain information as well, because it doesn't have the opportunity to file and store that information. When we do sleep really well, we reinforce our learning and reinforce the neural pathways that we formed because we're able to cement them through neurogenesis, which means that if we're going to learn a new skill, the more that we sleep and the higher the quality sleep, the better we're going to get in terms of retaining and perfecting that skill, movement, or desired outcome. Tied in with that, we have the pain response. And we're going to look at acute pain, short-term pain, which is a nervous system response to a perceived threat to the body. And there's 4 types of acute pain that we need to be aware of. We have nociceptive pain. A nociception describes the normal processing of pain and its response, which acts as a protection mechanism or a warning. So if we touch a hot stove, for example, our reflex or instinct will be to remove our hand because it will otherwise burn, causes damage. So in essence, nociceptive pain is a good thing because it warns us about potential danger. Inflammatory pain happens after an inappropriate response by the body's immune system. So it's swelling after a ligament injury, for example. So if you've ever damaged your ankle, your knee, or your shoulder, had a ligament problem, you'll find swelling. I had this when I tore my anterior cruciate ligament a few years ago. My knee swelled to the size of my hand, and I was walking around with a very swollen knee for a few weeks, which is my body's way of saying that it was trying to heal the area and protect it from further damage. We have neuropathic pain, which is nerve pain or nerve irritation, which comes from a dysfunctional posture or poor movement patterns. It's also things like compressed discs if you're sat at a desk all day, or it can come from poor technique, which causes impingements and pressures on the nerves. A common one, or a common example here, would be sciatica. So the sciatic nerve runs down the back of your leg from your hip, and it causes numbness and tingling in a lot of people who have it. And then we also have functional pain, which is pain without an obvious origin. That can be through technique, through poor mechanics, or what we call non-specific pain that we're not sure of why it happens. So just to recap the 4 types of acute pain: nociceptive, inflammatory, neuropathic, and functional. Okay, well now we're going to go into the senses and the 7 senses. You may have heard from common knowledge that there's 5 human senses, and primarily that's true at a base level, but we're going to go into 7 and see how this can break down even more. So some of the senses are touch, sight, hearing, taste, and smell, which are otherwise known as tactile, visual, auditory, gustatory, and olfactory. There are 2 more when it comes to movement and exercise. So one is movement itself, which is vestibular or kinesthetic, so doing, and the other one is body awareness or proprioception. So remember we've said at level 2, proprioception was positional sense awareness, so where your body's joints, muscles, ligaments, tendons are in relation to other structures in the body in a given movement. This moves into the learning process, which you may be familiar with things like VAC or VARC, which is visual, auditory, read, write, and kinesthetic. So do you learn primarily through seeing, listening, reading and writing, or from doing? Most people will be a combination of all of them with 2 dominant ones, or maybe just 1 dominant one. Now, that's all part of the learning process, but what we're going to break it down into here is a 3-stage approach of sense. So the first one is sensory, which is taking in information or sensory feedback from around you. Integrative is interpreting what that information means and what you're going to do with it. And then the motor response in itself is the physical or emotional response you have to that interpretation of information. So in other words, the action you decide to take. An example of this is the game of tennis. So you've hit the ball to your opponent. You then see your tennis opponent lining up to hit the ball back, but you read their body shape, where the ball is bounced, where they're potentially going to put the ball. Integrative is then seeing what that information means, so predicting where the ball is going to go and deciding how you're going to respond to their response. So what functions or motor functions do you need to perform to hit the ball back accurately? Once you've interpreted that information, your motor response is the actual doing of hitting the ball back to the desired place, and this is the getting into the right position and going through the gross movement pattern itself to be able to do that. So it's sensory first, integrative second, and motor response third. On the next slide, we're going to look at the learning process in a little bit more detail, in particular the 4 stages of learning. Some of you may be familiar with this if you have a bit of a coaching background or you've worked in project management, that sort of thing. And what we're looking at here is the 4 stages of competence. So the first stage of competence is unconscious incompetence. So as the name suggests, we're not even aware that we don't know how to perform the task or skill, or we don't know what we're doing wrong. Stage 2 is conscious incompetence. So we've moved forward a little bit here. We're consciously aware that we don't know how to perform the task or the skill, but we don't necessarily know how to do it correctly. But it's a step forward because at least we're aware of the limitation. Moving into step 3, which is where progress is starting to happen, we have conscious competence, where we are consciously aware of how to perform the skill or task, and we can perform it well on the basis that we're concentrating and putting conscious effort into what we're doing. And then the 4th stage is what we know as mastery, is mastering the skill or task, and it's become second nature, so we don't really have to think about it anymore on a conscious level, we just do it. So this is things like natural instinct and being able to do something you've done 1,000 times that just comes off the tip of the tongue, or you just kind of find your flow very, very quickly. That can be a sporting thing, it could be a movement in a gym, or it could even be anything from a language to learning a completely new job role. Looking at the learning process in more detail, those things are really important because we need both internal and external feedback to improve our desired outcome or our ability to perform a task or skill. But something that's really important, and one kind of tenet or phrase that I want you to remember going forward is the following: practice does not make perfect. Purposeful practice makes perfect. So one more time, practice does not make perfect, purposeful practice makes perfect. And this was said by a guy called Matthew Syed, who was a Great Britain table tennis player, I believe, who played at Olympic level. He's written a couple of books, one of them being Bounce, really, really good book that talks about this, and the 10,000 hour rule of 10,000 hours of purposeful practice is what it takes to master a skill. He's also written Rebel Ideas, and I believe there was another one, Black Box Thinking, which are all very good books. Definitely worth a read if you're interested in learning about the psychology, learning about how we learn, and learning about the nervous system in an indirect way. Off the back of that, we have a term called mind-muscle connection, which is quite commonly known amongst even regular gym goers. What they don't know is how it actually works. So the neuromuscular junction is where the brain releases a chemical called acetylcholine, which communicates with the muscles in the body. Acetylcholine crosses the synapses, binding to the receptors of the muscle fibers. And the better the communication here, the better the recruitment of muscle fibers, which will lead to a better lift or better output of performance of the desired task or skill. So the more mind-muscle connection, the better we perform. And this can be improved by consciously focusing or feeling into the muscle contraction of the targeted muscle group or muscle groups when performing a lift. This leads to better results aesthetically, like in terms of you will get better breakdown of muscle fibers to grow back for things like hypertrophy or fat loss, but you will also neurologically improve, assuming you've done things with purposeful practice, to a point that it becomes easier and more efficient the next time you do it. the back of this, there's muscle memory. And muscle memory is what I call a misnomer because it's often misunderstood. There isn't actually a thing as muscle memory. What actually happens is your nervous system and your brain are the ones that are responsible for remembering. Your muscles are just essentially an extension of your nervous system, so they do what they're told to do. So muscle memory is actually nervous system memory deeply embedded inside the CNS and PNS. And the thing with this is the more we do something, the better we do it through purposeful practice, the faster signaling, so the better we get. So if you think of this like if you drove a car for 10 years every day, and then suddenly for 10 years you didn't drive and went back to driving a car after the 20-year period, you're going to be able to remember how to drive a car relatively quickly because your nervous system is remembered through all those times of 10 years of purposeful practice of how to be a good driver, of what to do. But when if you only have a scenario where you've driven for a few months and then you stop for 10 years, you're not going to have the same level of nervous system memory built up because the crossing of the synapses hasn't happened anywhere near what it would have in the other situation. So the more you do something with purposeful practice, the faster the communications across the synapses, leading to more efficient processes. So this is the same in a gym situation. If you've done thousands of deadlifts on a particular weight or threshold, but then you've stopped training for 2 years, you're not just going to be able to pick it back up and do it at that weight without integrating yourself back in and getting back into the groove of things over weeks and months, or even years for some people, because you just don't have that muscle memory, now that we know what it means, in abundance as you need. And with that we have the synapses. So if you're not sure what a synapse is, it's quite a good diagram here in the top left of the synapse impulse passing through each other. So synapses are junctions between two nerve cells in which impulses pass through. Its function is to transfer electrical activity from one cell to another or from nerve to nerve. They're located between the axon and the dendrite, so if you need to look back at that picture from a few slides ago, highly recommended. It's also the better we move, the faster the electrical transmission, meaning the more we've purposely practiced, the more embedded it becomes into our nervous system, and eventually, after enough purposeful practice and time, we end up becoming unconsciously competent and second nature because it just becomes instinct to us by that point. We've mastered the skill or the task or the outcome that we've set out to achieve. What's also linked to this is central sensitization and placebo. So we have a protein called PKM zeta, which plays a critical role in building and maintaining neuromuscular memory, or muscle memory if you like, which happens through strengthening the connections as we've established. But some good examples of where this can also happen in a not so good way is the example of phantom pain, which is where a soldier might have lost a limb, but they still feel pain in the area where that limb used to be. So the stories of people in hospitals or wards or medical centres, soldiers crying out in the middle of the night, screaming of pain in their leg. The reality is they've had their leg blown off or amputated from an injury, because your brain can't tell the difference between what's real and what's not. What's also linked to this is placebo and nocebo. So placebo is believing something will happen enough that you get the outcome you believe. For example, if I tell you take this pill, it will make you feel better. If you believe that, your chances of feeling better will improve. And nocebo is believing that it won't happen. So take this pill, but it's not going to. Or if you take the pill believing it's not going to work, it might not work. We don't completely know the ins and outs of placebo and nocebo, but it is something that has been researched quite heavily in the world of pain research. What we do know is placebo was founded by Henry Beecher, who was a medic in World War II in the D-Day invasions in Normandy, where, if you're familiar with history, World War II, we lost, as the Allies, quite a lot of we lost a lot of people during D-Day, and placebo came about from Henry Beecher essentially having ran out of morphine to give to his wounded soldiers. So what he decided to do was give water to them, but he told them that it was morphine. And to his surprise, a lot of the soldiers actually stopped screaming and actually felt better and in less pain through injections of water, which was basically the birth of placebo research as we know it. Now, this is also linked into the endocrine system, which is the hormone system, which is got its own lesson in itself, which it deserves because it's a very in-depth topic. But I've put this in here because it does link to the nervous system, and we know that the nervous system is the master system, and no system works in isolation. So the role that the nervous system has in hormone production is very, very important. I said here chronic stress can lead to an excess of adrenaline and cortisol, the two major stress hormones, potentially leading to fatigue-related conditions such as chronic fatigue, adrenal fatigue, through the adrenal glands. Now, exercise is a key component of managing these hormones, but also managing pain, as it tells the nervous system to focus on something else other than the pain, providing that you are not deliberately going after the area of pain. So if you've got a sore knee and you're focusing on your knee, you're still going to feel the pain. But if you've got a sore knee and you focus on your training your shoulders, for example, you're not going to feel that pain as much as you would have, because your body is distracted. Your focus is on the area that is the most important. This is also important because prolonged pain has been shown to severely impair the immune system, and cortisol can also be caught in a negative loop, because the more you're in pain, the more you're going to produce cortisol, and the more your immune system drops, the more you're going to produce cortisol again. Here's just an example of some of the endocrine glands, but we will go into this in a lot more depth later. So what we have here is our scope of practice. So it's all well and good knowing this information, and it is useful because it helps us to build those relationships with osteopaths, physios, chiropractors, sports rehab guys, which gives us the opportunity to work with more clients. Now, we still need to really, as professionals, go into further education and do things like exercise referral and some specialist qualifications, possibly lower back pain, just to have a better understanding of pain science. But the door is open, and we have that trust element when we do have this fundamental baseline knowledge. What we need to remember is that as fitness professionals, we can't diagnose a condition unless we obviously have those extra qualifications. But even then, we still have our boundaries. We can give our opinion, but what we need to be careful is that with our opinion, that it can often be misconstrued. People can take it as literal, and we might not be right because we may have a limited knowledge of the body in that sense. So it's better to try not to give an opinion unless you have a very informed opinion to give. If a client suffers from pain that is from an unknown source of origin, we need to refer out to a medical professional, get that signed off. We may be able to then work with them when they come back, which is fine. But at least we'll have a better idea of what we're not allowed to do and what we are allowed to do. And what this can help us to do is work around a potential problem or an injury, depending on what it is. Some clients may need to be referred to a psychologist, cognitive behavior therapist, which is sometimes known as CBT, or an acceptance commitment therapist, which is known as ACT. And this may help to improve their relationship with pain, because the way the brain works, it can't always tell the difference between what's real and what's imagined. And with the likes of placebo and nocebo, people can be in pain by just thinking about the thing they want to do or are supposed to do. So they're in pain before they've even done it. So improving that can help them to help with their associated beliefs. For example, associating exercise with back pain because they slipped a disc or pulled a back muscle previously, they might automatically think of pain every time they go to think of exercise. So it's about healthy relationships with our pain. To help us work with that, we have a pain scale that is quite common across medical practitioners. Now, there's no definitive rule to this. It's a little bit like an RPE scale, sliding scale. But what is a good idea is to say that if your client is more than a 3 out of 10 consistently, it's a good idea to refer them out for recommendation. Now, with that, be mindful that it is subjective. Some people may have a lower threshold to pain and some have a higher. So you might have someone who's very sensitive to pain that says it's a 9 when it's more like a 5, and someone who says it's a 2 because they have a better threshold when it comes to pain tolerance. And really, it might be a 5 or a 6. So it is subjective. So the better you know your client, the more context and information you have, the more accurate of a position you're going to be able to pick up from this pain scale. You also have the faces, and the colours. So if the faces and the colours help, you can print one of these tools off and it will help you to work with your client by getting them to point, or maybe give them a better reference point to give you a more accurate representation. Okay, so coming to the end of this section, we're going to have a quiz as usual. So like everything else, if you want to pause it as we go, write things down. If you want to go back through the slides, it's entirely up to you, however you want to learn. So we're just going to go through the questions. Question number 1, what are the 2 main branches of the nervous system? Question number 2, how many pairs of nerves attach to the spine? Question number 3, what are the 2 branches of the autonomic nervous system? Number 4, which system is known as a state accelerator? So speeding up. Question 5, which type of nerves carry electrical impulses away from the CNS? Question 6, what is the stress hormone called, or the main one? I'll give you a clue, it begins with a C. Seven, what is the term for believing something will or won't work? So it's actually 2 answers here. So what is the term for believing something will work, and what is the term for believing something won't work? You would need both answers to score the point. Question 8. What is the term for a connection or junction between 2 nerve cells? Number 9. Name the fatty substance around the axon. So with that one, remember the protective layer around your luggage from the airport to the plane, the destination. And number 10, list the 3 motor stages for learning a skill. So the answers. The answer to number 1 is divides into the central nervous system and the peripheral nervous system. You need both to score the point. How many nerves attach to the spine? 31. Number 3 is sympathetic and parasympathetic, so accelerate and decelerate. The answer to 4 is sympathetic. 5 is efferent, so E for exit, E for efferent. The main stress hormone for number 6 is cortisol. So number 7 is placebo and nocebo. So it's actually my fault for not writing nocebo on. But placebo is you believe something will happen, and nocebo is you believe something won't happen or work. Number 8, the name is the synapse. Number 9, that protective layer is the myelin sheath. And number 10, the 3 components or phases, if you like, are sensory, integration, and motor. So as with all the other quizzes, score them up. If you've got 7 out of 10 or above, then well done, you're on the right track. If not, don't worry, keep practicing. These quizzes will help. A lot of the stuff that comes up in these quizzes will come up in your exam, or potentially will come up in your exam. It's stuff we've seen before. It's also a good opportunity to go back and do this lesson as many times as you want. Okay, just to finish off, we're going to look at the objectives from the start, have a bit of a recap. So, just a bit of a learning check. Are you now able to have a deeper understanding of the nervous system's role in health and exercise? Are you able to understand the differences in the different branches of the nervous system? Are you able to develop a thought process behind the how of the nervous system and how it underpins the other bodily systems, such as the endocrine system, the muscular system? Understand the difference between afferent and efferent nerves. Understand the importance of our language and our environment's role in homeostasis. And last but not least, are you now able to understand the basics behind pain and our boundaries as fitness professionals? Well, that brings us to the end of lesson 6. I hope you enjoyed that. If you do have any questions, feel free to send an email across to our team. We'll answer them where you can. Feel free to watch this as many times as you want as well. It sometimes takes a couple of run-throughs to really grasp the information. And good luck with the rest of your study unit on this. If you need any resources, remember the book Why Zebras Don't Get Ulcers is a very, very good book to read. I highly recommend it. And also do your own research around nerves and where all the different nerves are in the body, because it really is a fascinating topic, and the more you understand it, the more you understand movement, the more you understand behavior, and the more you understand real life application, which I think is the key between being a good personal trainer and being a great personal trainer. Anyway, I look forward to seeing you for the next lesson, and thank you for watching.